When it comes to graph questions, I prefer to situate myself, so I like to write down all the information I know, and I like to use colors to coordinate which graph goes to which equation. So first off, we'll make f of x yellow, and then we'll make g of x blue. Now for 5.1.1, they want us to write the coordinates of D. And as we can see, D is the y-intercept of g of x. So if g is the y-intercept of g of x, that means the x value is 0. So D will be 0, y, which we have to calculate. So we'll make g of x. So we'll plug in that into the equation. So y will equal to minus 4. Now we know anything to the power of 1, anything to the power of 0 is equal to 1. Therefore that becomes 1 minus 3. 1 minus 4. Therefore the y value is 3. Therefore the coordinates of D is 0.3. Now they want us to write down the range of G. When they're asking the range, they're asking the y values. So which values of y is g of x true? So g of x goes all the way to the point until this asymptote here. And we know from the equation that asymptote is equal to -4. Therefore, g is true for all values of y that is more than -4, which means we will write it like this. That's that. Now, sorry, I erased my yellow graph. Now they want us to calculate the coordinates of A. So A is this point here. A is the point where g of x is equal to f of x. But we also know it's along the x-axis. Therefore, the coordinates at that point, the y value will be 0. So we can make f of x equal to 0. So 0 is equal to ax. So since we don't have the full equation for f of x, we'll use g of x. So g of x will equal to 0. So 0 will equal a half to the power of x minus 4. And we will convert 0 to 2 minus x minus 4. Therefore 4 is equal to 2 minus x. 4 is also equal to 2 to the power of 2 is equal to 2 minus x. Therefore we can get rid of these parts and we focus on the exponents. So 2 is equal to -x. Therefore x is equal to -2. Therefore the coordinates of A is -2, 0. Now they want us to calculate the values of A and Q for the graph f of x. So we know this is a simple finding equation of a parabola. So we first know a normal formula is f of x is equal to a of x squared plus q. already have the point E of the parabola, which is 1, 3. So we're going to substitute that point in. So 3 is equal to 1a plus q. We'll keep that as equation 1. Now we also know another point on this graph is a, which we already calculated as negative 2.0. So we can also sub that in. And that will be equation 2. Oh wait, we can actually do something better. We can take the 4a to the other side. That will mean negative 4a is equal to q. That will be our second equation. So if we plug equation 2 into equation 1, that means 3 is equal to a minus 4a, which is equal to 3 is equal to, which is equal to negative 3a, therefore a is equal to negative 1. Once we have a is equal to negative 1, we can plug that into equation 2. So if a is equal to negative 1, therefore q is equal to 4. That solves that. Now, the next question wants us to find the length of CD. CD is from this point here all the way to this point here. So the only possible way we can find this length is to look for the y values of C and the y values of D and add them together. That will give us the length. Oh, sorry, not add them together, from minus them together. So we know C is the parabola and we know the Q value is 4. Therefore, this would make C's point 0.4. Now we know D's value because we calculated it. It's 0.3. Therefore, to calculate the length of CD, YC minus YD will equal to 4. I'm sorry. minus 3, which is equal to 7 units. For the next question, they want us to find the equation of a straight line that passes through A and D. So here we have to imagine there's going to be a straight line passing through A and D. And this equation will be y is equal to mx plus c. And we know how we work any equation from a straight line. We first have to figure out the gradient, and we have to figure out the y-intercept. So here, at this point, our y-intercept, we already know it's through A. Therefore, y equals mx plus c. Y will equal mx minus 2. Okay, sorry about that. What I meant, we have to look at the y-intercept, which will be point D, not point A. So therefore we know y is equal to mx plus c. Y is equal to mx minus 3. And that all is left is to calculate the gradient. For this we'll be using point A and D. So we know how to calculate the gradient. M is equal to y2 minus y1 over x2 minus x1. Therefore, y2, I'll let that be D, be minus 3 minus 0 over x2, which will be negative. I said that's going to be D. So it will be 0 minus 2, which should equal to minus 3 over 2. Therefore, the equation of a line passing through A and D is equal to negative 3 over 2x minus 3. That's that. Now for the next question, they want us to know the x values if f of x is bigger than 0. So f of x is our yellow graph, and they want us to know for which values is f of x bigger than 0. In other words, is it positive? So for which values is this graph above the x-axis? Because that's where it can only be positive. Because once it goes below the x-axis, it becomes negative. So you can see it's in between lines A and B. So since we know A is negative 2.0, B will also be positive 2.0. So going back to 5.4.1, x can only be positive or bigger than 0 when it's between negative 2 and 2. Because you can see this whole part here is positive. Now, they want, in the next question, 5.4.2, they want to know for which x values is f decreasing. So, f decreases from C onwards. And we know C is 0.4, and since we're looking at the x values, f decreases when x is bigger than 0. Okay, for question 6, it says the equation of the function g of x is equal to a over x plus q passes through the points 3.2 and has a range of y being an element from infinity till 1 and also from 1 till infinity. Now they're asking us to determine the equation of g. So we know whenever there's a over x, that means that's an exponential graph. Sorry, I made a mistake. We know when there's an a over x, it's actually a hyperbole. Because this equation can also be written as g of x can be equal to a to the power negative x plus q. Scratch that, sorry, I made a mistake. This is actually a hyperbole graph because this can also be written as a times x to the power of negative 1 plus q. So that means this graph is a hyperbole. So for 6.1.1, to figure out the equation of g, since we know point 3.2 already passes through g of x, we can just sub that point in. Therefore, g of x will be 2 and since we know the range of g of x, we can automatically assume that these points where it doesn't cross mean there'll be an asymptote there. Therefore, the value of q, which is the value of our asymptote, will be 1. So therefore 2 to a over 3 plus 1. And once we solve for a, will be 3. This will give us the equation g of x is equal to 3 over x plus 1. Now, they say equation of h is the axis of symmetry of g, which has a positive gradient. So when they mean an axis of symmetry, it'll be the line dividing the two graphs, which will basically mean that once that line divides the two graphs, the graphs will be equal of each other. So we know in hyperbole it goes like that. So the axis of symmetry will be somewhere things like that, will be somewhere in the middle like that. And once you fold over this top part to become the same as this part, it will be equal because they will be overlapping. So that eventually will mean that the axis of symmetry, as we know, will be x plus 1, since it's a positive gradient instead of x minus 1. Now 6.2 wants us to sketch the graph of g and h on the same axes, clearly showing all the asymptotes and intercepts. So that'll be our y-axis, and this will be our x-axis. We know our asymptote is +1. This will be y is equal to 1. So we'll go somewhere like this. And we need to calculate our x-intercept. So our x-intercept of G will be -3. And this will be this will be our g of x. And now we have to show our axis of symmetry, which is x plus 1, which will go through there. And this will be our x-intercept of -1. And that's all we showed. So we showed our asymptotes, we showed our x-intercepts for all graphs. We didn't show our y-intercept of h of x. So h of x is equal to x plus 1. So y will equal to 0 plus 1, therefore y is equal to 1. So that means the y-intercept of h of x is 1.0, which is in line with the asymptote. Okay. So now they want to know the equations of the asymptotes of f if f of x was -g of x plus 5. So f of x is equal to -g of x plus 5. And we know g of x is 3 over x plus 1. And we have to add 5 to that, which will mean that will be 3 over x plus 6. Therefore, f of x is equal to 3 over x plus 6. This means the asymptote of f of x will be this value here. So it will be y is equal to 6. Well, I'm sorry, I made a mistake. I forgot the negative value. So it's -g of x plus 5. So this will be negative open bracket 3 of x plus 1 plus 5. This will become -3 over x minus 1 plus 5, which will be -3 over x plus 4. Therefore, f of x is -3 over x plus 4, which will mean our asymptote will be 4. Y is equal to 4. Thank you.